Cool. So, I'm Thea. I'm VP of Product at Echo Analytics, and I have to say I'm really thrilled to be here because I'm actually on my campus, my alma mater here, and it's really thrilling to be here. Not just because of that, but also because I'm here with the brightest minds in geospatial analytics, right? So, let me talk about our origin story.
Closer to the mic.
Sure, thanks. So our origin story at Echo started with frustration. I'm sure we've all felt that before with data, geospatial data in particular. What happened was a year even before Echo Analytics was founded, we were approached by a company, an out-of-home advertising company that was looking for mobility data set matched to POIs to better segment their audiences, basically. What we discovered really quickly was that it was very difficult to get a POI data set or even several POI data sets with high quality data. What we saw was the problem was it was lacking, all of the data sets were basically lacking freshness, coverage, and accuracy even. It was quite a surprise to us because we felt that this was a given, right? POIs are everywhere and are abundant, but the quality was really not up to standard. So for example, you have a lot of instances where you have something called GPS grade standards. GPS grade standards means that, okay, if you're walking on the street and you have a POI and it's about, I don't know, 50 meters away, well, it's not a huge problem, right? You can find the location you're trying to go to. But if you're a data scientist, that's really problematic because you're dealing with millions of POIs. You need to analyze those POIs. You need to find the similarities within those POIs. And if things have 250-meter differences, it's very difficult to do that. It's very difficult to deduplicate POIs, for example. So what do you do in those cases? Well, what we discovered is we really needed something called data science grade POIs. Our founders actually, they're kind of crazy, but that's kind of why I wanted to join the company as well. It's because I was intrigued by what they were setting up. But what they did at that point was they actually drew by hand, I'm not kidding, 1,400 polygons manually. They quickly discovered this was not possible. This is definitely not scalable. So what they did was they decided to do something about it, which is when I came in. So what does a good POI database need? What I discovered pretty quickly is we needed places and we needed shapes. And if you've ever dealt with a lot of POIs, I think you guys are very familiar with them, is my assumption. And to me, they're really like Russian nestling dolls. So the more and more you work with POIs, the more and more you discover their complexities, and you see that you're peeling the layers more and more, and in the end, it makes you kind of want to cry. But I stopped crying at some point and decided to put a strategy in place. What I thought about was all of the steps, the important steps we needed to do in order to scale our POIs and have a very good quality POI data set. So what we decided to do was normalizing was super important, deduplicating the POIs, cleaning the POIs, enriching, refreshing, and obviously the extracting is really important also. Obviously, we wanted to source from as many places as possible. We had started sourcing about 4 to 5 different data sets. We discovered quickly that wasn't nearly enough, so we built and built upon that. We ended up with dozens of different sources. We had to get very creative with that. But our ambitions were also huge. We wanted to go from our first month, 10 million POIs ingested, and then every consecutive month, another 5 million added. So obviously the infrastructure of the data lake here is very important. You need something flexible. You need something that's going to allow you the possibility to do what you want with the data and not cost you too much, obviously, in storage as well. So, normalizing. I think you guys all know what this means, but just to take us back, normalizing is just standardizing the data. It seems super simple, but when you're dealing with about 30 different attributes, it can be quite a challenge. What you see here on the screen, for example, is that we had to deal with things such as phone numbers. So if you look at phone numbers, some phone numbers from different sources have international codes, some don't. So what do you do with that, right? You have to standardize across all different attributes in all different ways. You look at the brand names, if there are brand names, they're different. Some have accents, some don't. You have to look at the categories if those exist. There's a lot of things that you have to normalize along the way, and you have to make business decisions based on what you need to do with the data, and each one is going to be different. Then you have to do deduplicating. Deduplicating is something that you cannot do without normalizing the data, right? It's something that's really tough to do because of all of the different sources. They have all different attributes, they have all different formats, they have all different things, such as, for example, if you have geocodes, right? If you take geocodes, you have a geocode that maybe some sources use the center of the building, for example, for their geocode. Some use the street address. It's not a huge difference in most cases, but if you're talking about malls, that's a huge difference. And you can't really make decisions in a scalable way if you have those kinds of problematics, because even a human has a hard time making those decisions, right? What do you use? Do you use the street address? Do you use the center of the building? When it's a mall, you actually have several addresses, so what are you supposed to use? So even as a human, if you can't make those decisions, how can you expect an algorithm to make those decisions? So again, you're going back to the first place, the normalization piece is really important. You have to be thinking about the business rules you're putting in place for the normalization. That's going to help you with the deduplication later. And you want to duplicate on all different attributes. And we couldn't do it in a simple way because that requires too many compromises. What we put in place is a weighted scoring system, actually. And so it's not just a score for each attribute, it's a weighted scoring that allows us to not make those important compromises that we didn't feel comfortable with. So, for example, you're going to see different things such as which attribute is more important than others in certain situations. At first, by the way, we had 4 different buckets. We had a bucket called identical, one called similar, one called suspect, one called different. And unfortunately, the first time we ran our algorithm, can you guess what happened? Well, everything ended up in the suspect bucket, which meant that 99% of the database had to be done and checked manually, which kind of defeated our purpose entirely. So we definitely had to work on that. We had to do a lot of labeling, of course, at first by hand. We had to make important decisions about, for the business, what was important, what was not, in terms of the weights. But once that was done, obviously, now we have our machine learning algorithms doing the work for us and optimizing on those weights every time we have duplicates. So the next step here is cleaning. Cleaning obviously also builds on the previous steps, normalizing and deduplicating. But cleaning is a challenge in itself because what happens here is sometimes you get not just erroneous information, you have competing information, like completely different information for the same POI. Some sources may say that that POI is open. Some sources say it's closed. So which one do you believe? And here again, we didn't want to make important compromises on the data. And that was really an important choice. and a really strong part of what creates value in our POIs, because there are a lot of instances where you get a source that has better quality data and one that has more data per POI, right? So one may have 3 attributes, but you know they're trustworthy. Another one may have, I don't know, 15 attributes, but they're less trustworthy. But do you have to make those compromises? A lot of people actually do make those compromises. They use sort of, we started with this, by the way. They use simplistic logic, and they replace one source with another source, for example. And we just didn't want to do that. It was too important of a compromise. So we decided and developed something called our mix and match methodology. So in the end, what's kind of cool is that each of our POIs is sort of like a Frankenstein-like POI. It builds on itself, and we have POIs that are built basically sometimes from up to 30 different sources, and each one of those are chosen by our algorithm. So each attribute by country, by category, by source is chosen to determine which attribute fits best for that POI. Next, we have our enrichment. Enriching the data is really important because what happens here is there's a lot of POIs that are missing really relevant information for our clients. So brands, for example, can be missing. Taxonomies are a whole different ballgame, and polygons as well. What happens here, let's talk about brands first. So brand information, as I said, is really important for clients. They need to be able, like a lot of our clients come to us and they say, okay, I want to know how many Taco Bells there are in the US, right? But if you don't have the brand information attached to a POI, you can't do that. And as I said, a lot of the data sets didn't have this information. So what we ended up having to do is do this ourselves. And we did this by looking not just at one attribute or 2 attributes, but combining all of the attributes we possibly could in order to do this. So I think personally the most reliable attribute to do this with is the website, if it's available. The website obviously has a domain, and the domain name can be extracted in order to find out the brand. You have to be careful here, though, because sometimes, actually a lot of times, you have a lot of the smaller brands or even single POIs that don't have their own website. They may use a Facebook page. They may use, I don't know, they may use The Fork, right? Restaurants, they don't develop their own websites. They just use The Fork as a site. So you can't really use that as well if you have that. So you have to use, you can't rely on one thing like websites. You have to rely on a bunch of different attributes, as many as possible, basically. Our next one was taxonomies. I laugh because this is the 3rd time in my career I have to build a taxonomy system. I don't know why it keeps falling on me, but it does. And I kind of have a love-hate relationship with taxonomies because they're incredibly valuable, obviously. We do this. Our brains as humans work with categories, so we need them. But what we saw was that there wasn't a common taxonomy that everybody used, right? Some people use NAICS, some people use ISIC, some people use keywords. There's not a single taxonomy that most people use. So what do you do in those cases? What we decided to do was not build a categorization. We decided to build a taxonomy system that allowed us to map whatever taxonomy our clients needed us to map our POIs to. And the way we did this, again, was extracting as many keywords from all of the attributes that we had. So natural language processing algorithms did come in handy here, unlike when we did brand attribution, which I'd say even name entity recognition algorithms don't work that effectively in brand recognition, but here for the taxonomy and extracting keywords from the POI names, from the brand, if that exists, from the category of our client's category, if they have that in place, all sorts of information, as much as you can. You're going to be extracting keywords and basically adding those to a definition that's going to help you map whatever taxonomy you need to for your client. And to be honest, that's been a really big game changer for us, but also for our clients who just have had a really tough time, even just in evaluating samples, because if you don't have the same category in place, then it's really hard to do an evaluation. All right, so our next step was polygons. We heard from a lot of our clients that the open source polygons they were using were not the quality that they had hoped for, so we really wanted to do better for them. We used image recognition, obviously, satellite imagery to do so, but we're sort of hoping for a unicorn, as in something that doesn't exist, which is satellite imagery that isn't too costly. That's pretty much impossible to find. But what we didn't find was we were able to find a really good compromise between gridding imagery and good polygon quality. And the way we did that was we focused almost entirely on edge cases rather than on normal cases. And we did a lot of data augmentation, for example. We increased the shadows, and we did lots of things like that in order to help the algorithm really define things such as, well, in North Africa, like in Morocco, for example, the buildings are sometimes the same color as the ground. So that makes it really hard for image recognition to recognize a building, right? So that's the way we did it, was on those types of edge cases, buildings that had satellites or chimneys, clouds, all sorts of things like that. And that's what we fed in more than anything else, more than all of the normal cases. And then refreshing. Refreshing is unfortunately a really important part. Not unfortunately, but the unfortunate part was that once we had built what we thought was the perfect data set, well, the next day it was irrelevant because, POIs aren't static. Businesses close, they open all the time. So we had to find a strategy more than a technical way to do this, but it was basically reliant on having very strong relationship with our data sources, being able to trust them, being able to grade the sources themselves for each attribute, like we had done for our mix and match methodology and our deduplication methodology. And this allowed us to put automations in place that allows us to do the refreshing of the POIs as often as we need to, basically as often as reality reflects. And then extraction. I think, this is something that's a little bit obvious, which is, yeah, we need to extract the data at some point and make use of it. But what's important information to understand here is that you need to think about this at the outset. When you're building your infrastructure from the beginning, you need to be building something that has an incredible amount of flexibility in the solution itself. And you need to be thinking about what you can automate, right? Like I talk about automation a lot, but that's because manual work is death, pretty much, right? When you're dealing with millions and millions of POIs, you need to automate. And so what we did here was just put as much QA automation in place from the get-go and build the flexible solution that allowed us to do the flexibility and analysis that our clients needed. And finally, 6 months later, I mentioned we got to 30 million 6 months later, but now another 6 months later, I'm really happy to say well, it says 43 on the slide, but I think as of today, we're at about 45 million POIs. We, in the last week, I think grew by an additional 2 million. We just opened the US, Canada, and Australia even. And we keep growing, basically. It's pretty exciting, and I feel like we'll we'll just keep growing and growing and growing. But some of our use cases and why this is important is because obviously geospatial data is so important to all of our clients, and figuring out and finding the use cases that really have the most impact for things like FMCG or retail or governments even, prop tech, whatever it is really powerful. One of my favorite use cases was in the UK. There was a market research company that wanted to have a social change campaign around getting people to stop throwing their gum on the sidewalks. And so we helped them find the billboards with the most foot traffic. And that was a pretty cool use case for me. I love discovering new ones. I think it's one of the funnest parts of my job, to see how impactful really these things are. But anyway, almost done. I wanted to finish off anyway by thanking Carto. We're really excited to be here. It's been really eye-opening for me as well to meet a lot of you, hear what you guys are working on, hear some new use cases that I wasn't aware of. And I wanted to say we're really excited as well that we're now part of the Data Observatory. So you can find our data on Carto's website. And we're grateful to be there, and we're excited to be there as well.